Think about the last time you were stuck at a long red light. Like, what did you actually do in that exact moment?
Right, yeah. If you're like most of us living in the modern world, the second your car came to a halt, you probably felt that familiar itch.
Oh, absolutely. You reached straight for your phone to escape that sudden wave of boredom.
Exactly. Because we treat those blank spaces in our day as dead air, essentially.
Yeah, dead air. Something to be instantly filled up with a text message or maybe a quick scroll or, listening to something in the background.
Because you are busy. I mean, your life is this endless stream of inputs and decisions and constant movement.
Right. But the neuroscientists and behavioral psychologists we're looking at today are discovering something wild. They're finding that in those exact moments of absolute blank boredom, your brain is actually trying to perform a vital biological reset.
Which is so counterintuitive for a lot of people.
It really is. That blank static between the so-called important events of your day, it isn't dead space at all. It might actually be the most important broadcast your nervous system is receiving.
Because, I mean, we've spent the last few decades culturally obsessed with optimizing our lives.
Oh, for sure. Productivity hacks everywhere.
Exactly. We try to eliminate every single tedious or boring task. The drive for peak productivity basically has us viewing chores and wait times as the enemy.
The enemy of progress, yeah.
But what the current research is revealing is that we have been completely unaware of the heavy lifting those incredibly boring parts of our day are doing for our underlying biology.
And that is exactly our mission for this deep dive. We are exploring the science of the mundane.
It's a great topic.
It really is. We've gathered this fascinating stack of psychological notes and neuroscientific research, and it's all focused entirely on everyday routine behaviors.
The stuff we completely ignore.
Exactly. Our goal is to peel back the layers of your seemingly boring daily routines and uncover how these incredibly mundane activities are actually the secret drivers of your mental health, your brain function, and just your fundamental emotional survival. Okay, let's unpack this, because by the time we're done here, you are never going to look at washing a dirty plate or waiting at a traffic light the same way again.
I know, I don't anymore.
Right. But before we dive into the physical hardware of the brain, we first have to understand how psychologists actually define and map these behaviors. And looking at the sources, it is actually quite surprising how long it took the scientific community to even care about this stuff.
Oh, it really is. I mean, for the better part of a century, the psychology of the everyday was essentially a blind spot in academia.
A total blind spot, yeah.
If you think about the grand hierarchy of human behavior, early psychologists were just naturally drawn to the extremes.
Which makes sense. They secured funding to study, profound trauma or acute emotional distress.
Yeah, or high-level cognition and really complex social dynamics. The idea of setting up a controlled study to just observe the internal state of someone waiting for a bus.
Or folding their laundry.
Exactly. Folding laundry. It just seemed like a frivolous waste of laboratory resources to them. Routine actions were categorized as psychological dead zones.
Just dead zones.
Yeah, basically just the white space on the page of human experience.
Which is wild when you consider that those routine actions make up something like 80 or 90% of our actual waking lives.
Exactly.
I mean, we aren't living in a constant state of acute emotional crisis or, high-level philosophical debate. We're mostly just making coffee, commuting, and taking out the trash.
And that realization, that 80 to 90% realization, is what caused a massive paradigm shift in the field.
Thank goodness.
Right? Researchers finally started looking at the white space on the page, and they realized these so-called dead zones are highly active, deeply ingrained process that we actually rely on to function.
And the sources point us directly to the foundational architecture of these everyday moments, which was really popularized by Charles Duhigg in his work on the science of habits.
Yeah, the power of habit.
Yes. He maps out how we construct these routines through something he calls the habit loop.
Which is such a brilliant framework. The habit loop essentially breaks down our most automatic behaviors into 3 distinct measurable stages.
Right.
You've got the cue, the routine, and the reward.
Okay, let's bring this to life for you, the listener, because the sources provide a really elegant, highly relatable example of this loop in action.
Yeah, the morning routine.
Exactly. Think about your morning. Stage 1 is the cue. The cue is basically an environmental or internal trigger that tells your brain to just drop into automatic mode.
Right. So let's say the cue is turning off the water and finishing your morning shower.
Okay, shower ends.
You grab your towel, The physical sensation of stepping out of the shower registers, and boom, the cue has been activated,
And following that trigger, you enter stage 2.
which is the routine itself.
Right, so you walk into the kitchen, you grab the paper filters, you scoop the grounds, pour the water, and brew a pot of coffee.
And the defining characteristic of this stage is the total lack of conscious friction.
Like you're not thinking about it at all.
Not at all. You aren't standing in your kitchen actively analyzing the mechanics of the coffee maker or, deliberating over the water to bean ratio.
Your body is simply executing a sequence of physical movements.
Right. And then we hit stage 3, which is the reward.
The best part.
Oh, absolutely. This is the neurochemical payoff that helps your brain figure out if this particular sequence of actions is actually worth saving for the future.
So in the coffee scenario, the reward is multifaceted, right?
Yeah, it is the smell of the roast, the warmth of the mug in your hands, and eventually that really sharp feeling of being awake and alert.
So the loop is complete. Cue.shower ends. Routine.brew coffee. Reward, feel alert.
What's fascinating here is that this programming is entirely accidental for the vast majority of us.
Accidental, how so?
But you didn't sit down one day with a spreadsheet and consciously design this morning coffee loop to maximize your waking efficiency, right?
Oh, definitely not.
No one does. Your brain is essentially a prediction machine. It's
Right.
constantly looking for ways to streamline its workload.
Okay, so it recognized the sequence, felt the dopamine spike from the reward, and just
And use that dopamine as a save button.
a save button. Wow.
Yeah, it quietly locks the behavior into place. And now, it just governs how your day begins without requiring a single ounce of conscious effort.
I look at this and it feels exactly like writing basic if-then code for a computer, but like applied to the human experience.
That's a perfect way to describe it.
Right, like if shower ends, then brew coffee. If red light appears, then check the rear view mirror. If dirty plate enters sink, then grab the sponge.
Exactly.
It's like we are programming ourselves with these tiny background scripts of code and we're just walking around executing them all day long.
That analogy actually captures the mechanics of this perfectly. We are operating on a vast library of these if-then background scripts.
Which is a little spooky, but also amazing.
It is. And establishing that we are programming ourselves psychologically leads us directly to the physical reality of the brain.
The hardware.
Right. Because if this code is being written, where exactly is the server? Where is the hard drive storing all these behavioral scripts?
And this brings us to the neuroscience outlined in our sources. If we were giving out an award for the hardest working, yet totally least appreciated region of the brain, it would absolutely go to the basal ganglia.
Oh, hands down. The basal ganglia is this ancient, deep-seated cluster of neurons located near the base of the forebrain.
Caked in the brain.
Very deep. And it is the physical hard drive where your habit loops are actually stored.
Okay, so how does it store them?
To understand how it works, we really have to look at the concept of chunking and neuroplasticity.
Chunking, like grouping things together.
Exactly. When you perform an action for the very first time, let's say you are learning to drive a car with a manual transmission.
Oh man, that's stressful.
Super stressful. Your brain is firing on all cylinders.
Yeah.
It is processing the resistance of the clutch pedal, the sound of the engine RPMs, the visual data from the road, and, the spatial awareness of the gear shifter.
It's an overwhelming amount of raw data.
It really is.
Huh?
But as you repeat that action day after day, the basal ganglia takes over.
It learns the pattern.
Yeah. It leverages neuroplasticity, which is the strengthening of synapses between neurons, to bind all those separate data points into a single cohesive unit.
It chunks the sequence together.
Exactly. So years later, you aren't thinking about the clutch or the RPMs. You are just driving.
And we have to contrast the basal ganglia with the other major player in this dynamic, right? The prefrontal cortex.
Yes, the CEO of the brain.
Right. If the basal ganglia is the background software running quietly on your computer, the prefrontal cortex is your CPU and your RAM.
Exactly. It is responsible for logic, complex problem solving, overriding impulses, and basically navigating entirely novel situations.
And just like a computer CPU, the prefrontal cortex has really severe limits on its processing power.
Oh, huge limits. Conscious decision-making is incredibly taxing on the body.
Right, it burns through glucose at an astonishing rate. We experience this physically as cognitive fatigue.
We've all been there by 2 p.m. on a Tuesday.
Oh, totally. If your prefrontal cortex had to consciously process every single micro decision required to navigate your day, like how much pressure to apply to your toothbrush, or how to turn the steering wheel, or which way to turn the sponge on a dish, you just drain your battery completely.
You'd crash.
Yeah.
You would experience total decision fatigue by mid-morning. And this is exactly why the transfer of control to the basal ganglia is so vital. It is a brilliant evolutionary mechanism for energy conservation.
Because it's saving that glucose.
Exactly. Because the basal ganglia relies on those chunked, highly optimized neural pathways, it executes the routine with almost zero metabolic cost.
Zero. Wow.
Very little glucose. So while the background software handles the commute or the laundry, your CPU, the prefrontal cortex, gets to power down.
It gets to rest.
Yes, it conserves its battery life, remaining fresh and fully charged for when an unprecedented problem or a complex social interaction actually demands its processing power.
Here's where it gets really interesting, because looking at the listener's perspective, I have to step in and push back on this a little bit.
Okay, let's hear it.
Well, we live in an era that preaches constant mindfulness.
True.
We are told relentlessly to be present in the moment, to anchor ourselves to our daily actions. If my prefrontal cortex is basically going into sleep mode while I fold the laundry, and I am letting this ancient basal ganglia run my body on an if-then script, aren't I just sleepwalking through my life?
This is a fair point.
Because the way we talk about being on autopilot is almost always negative,
Yeah.
as if we were failing to fully experience our own existence. Is it actually a good thing to be on autopilot?
It's a totally valid tension. I mean, it really encourages critical thinking about how we spend our time. But we have to separate the philosophical idea of mindfulness from the biological reality of cognitive load.
Okay, how so?
Well, autopilot certainly has a negative reputation in popular culture. We tend to equate monotony with checking out, and we view checking out as a waste of time.
Right, like we're being lazy.
Exactly. But the neuroscientific data we are reviewing frames this entirely differently. From a biological standpoint, operating on autopilot during mundane tasks isn't about checking out. It is a critical mechanism for emotional survival.
Let's drill into that, because emotional survival feels like a very intense way to describe the act of washing dishes or driving home from work.
It does sound intense. But to understand the intensity of the term, we have to look at what the modern environment actually demands of our nervous systems.
Which is a lot.
A ridiculous amount. We are not living in the environment our brains actually evolved to handle. Today, we are subjected to a relentless barrage of novelty.
So much novelty.
Your phone is constantly pushing new information, your inbox is filled with unexpected demands, social dynamics are increasingly complex, and we are forced to make hundreds of micro decisions every single hour. If your prefrontal cortex had to remain fully engaged and present for every single input, if there were no background scripts to rely on your nervous system, would interpret that constant novelty as a threat.
Because novelty, from an evolutionary perspective, means unpredictability.
Exactly.
And unpredictability means potential danger.
You hit the nail on the head. When the brain is forced to constantly process novel, unpredictable information, it signals the amygdala to stay on high alert.
The fear center.
Right, the sympathetic nervous system ramps up. Now, we know our listeners are well versed in how cortisol functions as a mechanism for acute physical action, fight or flight.
Right, the alarm hormone.
But what we are dealing with here is a chronic, low-grade activation. Confronting unfamiliar demands constantly, day in and day out, creates an unending trickle of cortisol.
Just a slow drip of stress.
Yes, we are maintaining a baseline of physiological anxiety. The system never gets the signal to stand down.
Wow.
And sustaining that elevated frequency is deeply damaging to our cognitive elasticity and our emotional regulation.
So the mundane routines, these habit loops managed by the basal ganglia, they actually act as an antagonist to that chronic stress response.
Exactly.
By engaging in a predetermined, highly familiar task, we are essentially stripping all the novelty out of the environment.
Yes, the brain knows exactly what is going to happen next.
Right, like there are no surprise emails hiding in the sink full of soapy water.
Thankfully, no.
And there are no complex social negotiations required to just fold a towel.
Right, and that predictability is exactly what the nervous system is craving. When you drop into a routine driven by the basal ganglia, it sends a really powerful safety signal to the amygdala.
It says we are safe here.
Exactly. The environment is controlled, the outcome is known. Because no active processing is required from the prefrontal cortex, the sympathetic nervous system finally downregulates.
So the parasympathetic system, the rest and digest mode, takes over.
Yes. The cortisol levels begin to drop, and the physiological strain on your body physically diminishes. This is why routine provides such profound emotional comfort. It acts as a built-in biological shield against the chaos of an unpredictable world.
So what does this all mean? It means we need to fundamentally reframe our relationship with our own boredom.
I couldn't agree more.
For you, the listener, I want you to really internalize this the next time you find yourself dreading an everyday task. That boring commute where you know every single turn, or that pile of laundry on the bed, that monotonous evening dishwashing routine, it isn't a trap keeping you from doing something more productive.
Not at all.
It is actually a built-in sanctuary. I mean, many people recognize the immense value of a dedicated meditation practice to lower their stress levels, but they also find it incredibly intimidating to try and schedule a 30-minute silent retreat into a chaotic Tuesday.
It's just not realistic for most people.
Exactly. What this research tells us is that your brain is already seeking out its own meditative state. It is finding peace, lowering cortisol, and downregulating your nervous system through the mundane. Your dishwashing routine is the exact sanctuary your prefrontal cortex desperately needs when a formal meditation session just isn't going to happen.
If we connect this to the bigger picture, mastering this dynamic really changes how we approach our daily energy reserves.
How so?
Well, accepting the profound wisdom of routine and recognizing these moments of autopilot as purposeful energy conservation, it allows us to build incredible resilience.
Resilience. Okay.
Yeah. When you allow the basal ganglia to do its job and you let the prefrontal cortex power down during the mundane, you are actively banking your cognitive and emotional resources.
We're saving up for the real problem.
Exactly. So when an actual crisis does arise, when life presents an overwhelming situation or a sudden career shift or really complex family dynamic, your CPU is fully charged. It's highly present and it's actually ready to handle it.
Right. You remain resilient in the face of genuine chaos, precisely because you allowed yourself to experience boredom during the calm. That is such a powerful takeaway to pull from this deep dive. We have covered a lot of fascinating ground today, unpacking the hidden life of our most boring habits.
It's been a great discussion.
We started by looking at how Charles Duhigg mapped the psychology of the habit loop, revealing how our brains write those if-then background scripts of cue, routine, and reward to streamline our lives.
And then we moved into the hardware. We watched the hardworking basal ganglia utilize neuroplasticity to basically chunk those routines together.
Which allows our metabolically expensive prefrontal cortex to conserve its battery life.
Right.
Which ultimately leads to the most important payoff for our mental health, creating a biological shield against modern chaos. We learned that the sheer monotony of everyday tasks downregulates our nervous system, lowers our chronic cortisol levels, and provides deep emotional comfort in a highly unpredictable world. It turns out, engaging in our most boring chores is one of the primary ways our bodies are keeping us sane.
This raises an important question, though.
Yeah.
Especially given the current trajectory of modern life.
Oh, okay. What's the question?
A provocation, really, for us to consider moving forward. If mundane tasks are our brain's natural evolutionary mechanism to lower cortisol, signal safety to the amygdala, and recharge the prefrontal cortex, what happens as we continue to innovate?
Innovate, like with technology.
Exactly. What happens when we fully integrate artificial intelligence and smart home automation to completely eliminate all the boring chores from our lives?
Oh, wow.
If robots do the dishes, algorithms manage our schedules, and cars drive themselves, are we accidentally depriving our brains of the very autopilot sanctuaries we absolutely need to survive the chaos?
Wait, are we optimizing away our built-in biological stress relief?
It's very possible.
That is a brilliant and honestly slightly terrifying thought to chew on. So, to you, the listener, thank you so much for joining us on this deep dive into the science of the mundane. The next time you find yourself standing at the sink with a sponge in your hand or staring at that red light waiting for it to turn green, resist the itch.
Yeah, leave a phone in your pocket.
Don't reach for your phone. Don't try to optimize the moment with another podcast or an email. Just let the background code run. Let your prefrontal cortex take a much-needed break and allow yourself to enjoy the beautiful, protective science of doing absolutely nothing.